Hello, my name is Alex Ollman. I'm the product manager for HPE Ezmeral software, who predominantly works in the underlying software infrastructure for data and AI. And today, I'd like to go and start unpacking not just that software infrastructure, specifically around generative AI, but also the hardware infrastructure, and how being able to have that appreciation for, because what we were talking about earlier in the previous conversation was an appreciation for all of the steps along the way. We didn't even touch on appreciating all of the underlying infrastructure that is needed to perform any one of the 7 steps along the machine learning operations workflow. And so I wanted to talk about here the underlying infrastructure here and what we have delivered through private cloud AI. And I wanted to take you all on a story whilst I'm doing a live demonstration of the private cloud AI platform, because I think it is probably the best way I could describe not only the work that HPE has put into our private cloud AI offering, but also a reflection of the conversations that we have, not just with infrastructure managers, database administrators, but also those who are actively working to build the next generation of innovation for enterprises. That is the data scientists, data engineers, machine learning engineers, AI engineers, and application developers. So, with that, of course, I'd like to start here with, of course, as a few of you in the room, no one in particular, but would know that all good conversations with HPE start with HPE GreenLake. So this, I think, private cloud AI as an offering is the cultivation of that vision that HPE started when it first branched off from Hewlett Packard all those years ago. Seems like a long time ago, doesn't it? It's only about 9 years. 9, 10, 8 years. And that vision was 2 things. Firstly, is that HPE as a company wanted to go beyond simply being an infrastructure vendor, simply providing the boxes, the software, and for people to say, yep, thanks very much, we'll take it from here. We realized that the expertise of building solutions for any given use cases, no matter how complex, no matter how technical, no matter how otherworldly in the case of the 60s and 70s, we could leverage through delivering a holistic solution. We wanted to start moving towards solution selling. We didn't want to compete in a world that saw the abstraction of infrastructure, particularly for people wanting to get started. I don't need to buy a server, put it in a rack and run it, just the one for my personal website. We saw that people are going to start getting value out of public cloud vendors. But we knew that as time went on, that abstraction of infrastructure starts to become not only a cost burden, but a burden around data sovereignty, and a burden in terms of understanding and owning that end-to-end life cycle of infrastructure. And we realized that that's the world we want to live in. That was the vision around hybrid cloud. And private cloud AI is the cultivation of that vision, in that it is now delivering. It is probably the truest manifestation we have of delivering a cloud experience where that infrastructure is abstracted from an end user, but is still perfectly available every step of the way to be delved into, dug into, owned if they want to swap out the networking, swap out storage, because it's still in our customers' data set. They own it. It's sovereign, it's theirs. And I'd love to show you as to why, particularly pertaining to end users that are going down the line of generative AI. I'll start by taking what private cloud AI is. Private cloud AI is an infrastructure stack that is being sold as an appliance to be able to perform data engineering, data science, and machine learning in the age of generative AI. In the same way that a microwave 50 years ago, 60 years ago was an appliance, abstracting a number of the different things required to make and heat up food. I have food, I stick it in the microwave, my desired end product is the same. I have now abstracted a lot of those underlying steps. And private cloud AI does so by having, firstly, curating the software, hardware, networking, storage, compute, all the way down and all the way up in terms of being able to take a single application, a containerized application, automatically provision, scale it across infrastructure, and be able to do so through not just in terms of the management of application, but the management of users from cohesive consoles for individual personas. The three personas that I want to talk about in particular are firstly that cloud administrator. And when I say cloud administrator, it's a role that abstracts things like infrastructure managers, cloud vendor managers, database administrators, those who manage infrastructure and the access to it. And what they would want to see is a way to be able to take that infrastructure, that private cloud AI solution they've just purchased from HPE, and be able to deliver it and spin it up and deliver it as quickly as possible to those who need it. The desire of an AI administrator would be able to onboard people onto this infrastructure that the cloud administrator has just provided, be able to perform identity and access management, but not through every single application, to connect every single data source. They are able to do so through a single pane of glass. Lastly, the AI developer. Those personas I mentioned earlier, data engineers, data scientists, machine learning engineers. They want to just get started with what the work they need to do. They're highly trained in a very specific domain, and that domain was not SSHing into a VM that the IT department has given them to set up a Jupyter Notebook environment and then connect that Jupyter Notebook environment to, in the case of data engineering, something like Apache Airflow or a Pachyderm. It wasn't the data scientist's job to have to spin up multiple nodes and create an orchestrated mesh of Spark workers to a Spark controller. They just want to run a query on a database. So what does that look like in terms of abstracting all of that from the end user? It starts firstly here with being able to go and manage users from a single place. And what does this management look like? Well, I'm able to assign given roles to different sets of infrastructure. Maybe I have one instance of private cloud AI, maybe I have several. But as an administrator now, I can delegate individual users, whole teams, not just access to infrastructure, but what they're allowed to do on that infrastructure. And that, as you will see later, also extends to what data they are allowed to access. I can do so here without needing to log in and authenticate that user with that data set, with that data source, I should say. And anyone who has stored an AWS private key in a notepad on their desktop will know what I'm talking about. So I can do that. I can assign those roles. In the case of this particular private cloud AI cluster, I can make my good friend Abhi a private cloud AI administrator. You may have noticed there a little tag that said limit resource access for those that were a little more, I'll actually bring it up there again. Because we'll get into it in a little bit of a moment, but we can set further limitations on that user as far as resource access. And those resources aren't strictly infrastructure. They aren't strictly, here are the nodes that you're allowed access to. CPU, GPU, memory limitations. No, they also extend to individual tables and individual buckets in structured and unstructured data, not only structured data sources, but also object stores as well, as you will see in just a moment. And why is this all really important? Well, because today, if a data engineer, by the way, by clicking launch, this particular workspace here would otherwise click launch. It would take me to my data services cloud console here. However, this is now going to tell me I have access denied because of a maintenance work that was happening this morning, and I tried desperately for them to postpone it. But otherwise, we would have a nice launch button here for this particular environment, my private cloud AI instance. I am a data engineer.
So I'm assuming, okay, so you put the different roles and responsibilities that were over there on there that you had to drop down there. Within the stack that you're delivering, once it goes into the client, are you, the client, having to establish those roles? And then how does that click through in terms of their permission kind of capabilities, et cetera? How does that all, or are you going to show us that?
I am, that's why I'm really glad you're about to show. This is fantastic, by the way, because these are sort of questions that if they are lingering other people's mind here, please ask them, because it means that either we're about to go through that together or I can answer it directly as well. So those, yeah, as you alluded to there, those roles are going to mean that they can be passed down into the platform. So in signing into my GreenLake Cloud platform, either as an administrator or a developer, an end user, I now have authenticated access to this private cloud AI cluster with the roles that were just defined by those infrastructure and AI managers, those administrators. But what does that look like at a platform level? Well, it looks like the ability to take individual data sources, in this case here, these are specific tables, and this data source is public to all users. You cannot restrict access for individual users. But what we're actually seeing here is an individual table from an individual data source, in this case, a Postgres database that will contain many tables. And I can actually, I can view those tables as well. Yeah, there is in that public table here. Now I can view that table if I like. And I can find the schema, and there we are. Now, I would like to just sort of describe to you what just happened there. I, as a data engineer, logged into this platform. My AI administrator had gone through, spoken with the database administrators saying, hey, we're using this private cloud AI instance to build a level 1 support chatbot for our organization, externally facing. We need to pass certain documents, but we also need to be able to pass effectively historical data that we can potentially perform an SQL query on in real time to give a more accurate, nuanced answer to a specific use case. Maybe that table is pertaining to a user, and these are all the transactions that they have made with their bank. A common question that we all run into when we call up a bank is around specific transactions. They're all more often than not going to be stored in structured data sets. So that's what we would like. We would like that chatbot. That will require PDFs and documentation that are relating to the bank's policies. They're also going to need that structured data that is relevant to that user. I, as an AI administrator, can go and connect with people who own and manage those data sources. I can get the authentication required for those data sources, and I can make this connection. I could be a Snowflake database, an Oracle instance, support for Iceberg tables as well, MySQL and Microsoft servers, Microsoft SQL servers as well, and they can be already established. And with the credentials that I was passed by the person managing this administration, this is really important, not every single member in my team that need access to this database, just me.
What is Delta Lake and Iceberg? So
a Delta Lake is the way I like to use with Delta Lakes is like a Parquet file.
Okay.
And it's a type of file format. It is usually associated with being able to query large data sets. So if you want to say perform an SQL query,
yep,
and you take the resulting SQL query, you can save it in like a CSV file. You can also save it in a Parquet file. And that connector is usually associated with Delta Lakes. Iceberg tables is another structured data format. And if there is anybody here that has more experience with either of those two data formats, you're more welcome to jump in and give a more detailed answer there.
I think what's really interesting here is just the interaction with the raw data. I think that's something that we've not really seen yet. It's usually been an abstraction layer above the raw data.
Yep.
I'm not sure whether this is a good or a bad thing, but I think one of the things that you've talked about is roles. So I'll convert that into a question.
Sure.
I want to know about like the metadata that comes through with the tables,
yep,
and the fields and stuff, because that table could be anything, right?
That's
I
right.
could be guessing what it is. So does that information come through, and does that help to guide the roles and who has access to what? So
yeah,
just a bit more, I suppose, a bit of scaredness about digging into very granular data as the core point.
Of course, and that I think is where we didn't want to step on anyone's toes in terms of database administration. If people are managing their data sources, there's a good to fair chance they know what is in them. And instead of delivering a platform that says, hey, connect and go nuts, you still require that level of authentication, that user and name and password from that database administrator. And with that, there would be some contextual, it would need to be per organization, understanding of what is in that data source, what tables that you're actually giving access to. Because keep in mind, when I go and get access to a Microsoft SQL server, my user is only going to receive access to certain tables. And so with that, I can now create this connection here. So this in this case is just a Postgres server. I've made this connection, and the best part about it is that every user on this platform now has access to that one authentication. Everyone now has access to that data source. Here's the best part though. That same connector that allows me as a user to have access and run, in this case, on this particular table, a SQL query, and then generate that SQL query and save the resulting asset as a local asset in terms of a CSV, a Parquet file. I can save it as whatever I like. That same data connector allows me to connect the same data sources to any of the tools on this on AI Essentials, which is our software platform within Private Cloud AI. I'll explain what that means here. I go to my tools and frameworks. These are applications, and I'll get into the NVIDIA AI Enterprise stack in just a moment, but these are applications that come pre-installed, pre-packaged, pre-connected and pre-configured with Private Cloud AI on AI Essentials. So in the case of data engineering, for example, let's take the life of a data engineer. If I've just been on board into a team, I would need to go to my manager and say, hey, just to confirm, you've asked of this job, this level 1 support for a bank. I'm then therefore going to need access to customer data tables, stored and structured data sources. I'll need that authentication. I'll need all the files that we are storing and constantly updating in a volume somewhere. Maybe it's all our policies. Maybe they are stored in a cloud vendor environment somewhere, maybe as objects in S3. I will then need a way to build data pipelines to extract data from those data sources in real time with a customer query. And I'll need to do that with a tool that is designed to take data from a data set, perform some kind of transformation to it. That is to say, instead of taking all of the customer's data, just something that's relevant to their specific query, and then loading it into a place, putting it somewhere that is accessible to a large language model application in real time. Extract, transform, load, a data pipeline. And the most popular open source tool has been for many years now, and every master's student in this country studying data engineering will know how to use it, is Apache Airflow. That is also something I will need a node for to contact my IT administrator to spin up and get started. And keep in mind, I need to authenticate not just Airflow and myself to those data sources, but also a development environment. So I can write those pipelines either with R or with Python. And the most popular kind of development environment is a Jupyter Notebook. So I would need to spin up, I would need to make yet another IT ticket. I would need to spin up a Jupyter Notebook server. I would then need to connect that node that hosts that server to my Airflow instance, to my other data sources yet again. Or I could log in to Private Cloud AI, hop into my Jupyter Notebook environment as I am here. And in the case of this particular notebook, this here is where I can authenticate the token, the internal token that is used to pass information and authentication through every container on the Private Cloud AI platform. I can then connect to our S3 instance. That is a local S3 store at the storage layer. Again, pre-configured, pre-authenticated. And I can see all of the buckets that are associated with this environment that I have access to, keep in mind. If I change my bucket access and I run that same request again from my user, I will get a different list. I have not had to do any of the underlying infrastructure work to get here. I, as a data engineer, have logged in and got started. And that is where we extend it to not just data engineering and say, hey, I want to perform a query on a monstrously large table, and I need to do so by distributing that query over multiple compute nodes. For those that have done a VLOOKUP on a particularly large Excel file on your laptops, you'll know that usually takes a couple of minutes. In the case of millions of rows, tens of millions of rows, and hundreds of columns, you'll be there all day. So we distribute it over very high-powered compute nodes at the infrastructure layer. And we do so through a distributed big data query engine. In this case, Apache Spark. It's a controller worker type of application, which requires setting up that infrastructure, installing the control, setting up the control node, connecting it to its worker nodes, being able to pass jobs to it. So it means you need to authenticate to. You guys get the idea. If I want to run a Spark query in a notebook, I can do so by writing manage_Spark. The same way I wrote update token, I can go manage_Spark as long as I'm running the Spark kernel that we've written for that. And then I can run Spark jobs right from a notebook. Again, we are not taking away any of the steps associated with large language model deployment. We are taking away the steps associated that an end user does not need to concern themselves with as far as infrastructure. They just want to get started. But other personas whose job it is inside an organization to worry about the infrastructure, they have complete autonomy end to end over that infrastructure, hardware and software. And we extend this to data science as well. So if I want to say, take the data set that maybe this is not in particular for this chatbot here, I actually want to go through customer data that is, we found in this particular chatbot instance, or even just our testing, that these queries are going to come up more often than not. Maybe I can get my data engineer to give me a data set that removes customer IDs, but demonstrates the types of transactions that are most common with level 1 support. I can then create a small predictive model that is able to automatically tell, based off of a given natural language query, what transactions, the type of transactions, the fields I would be looking for with the most common queries. I can create a small predictive model. And where would I put that predictive model? Well, if I'm working on it once, I would want to just store it as a file. But that's not how modern machine learning works. You are constantly iterating, making that model better, working with tens of models, hundreds of models, multiple people working on the same model at the same time, and we do so through an experiment. There is one model in production, but 10 experiments on that model in any given time, making sure that new data being introduced doesn't cause that model to drift or get inaccurate. We also make sure that that model is maintaining its accuracy, not just over time with new data, but also as new data comes in, it isn't going to be biased as well. So in that case, we need to store that model in a model registry. All my different versions of multiple experiments, but I put one in production. Well, a model tracking platform for experimentation with a model registry built in, that's MLflow. And again, if I want to work with MLflow on this environment, as I mentioned, every data source is connected to every application here based on authentication. There is the bucket that MLflow uses to store models and training run log data temporarily. I can see it here. I can also...
A question for you. Sorry.
Yeah, please jump in.
Speaking. So just to help me understand how this works, what is the way organizations can consume that, and is there kind of an entry barrier or something like that? Because not everybody is an HP client. Not everybody may want to go with a multi-year contract with you guys if they just want to kickstart something. So is it something that you can just start running without having to go into lengthy negotiations and stuff like that?
Are you referring there to the software that you're sort of seeing here and that orchestration?
No. I'm talking specifically about the offering that you're showing, right? The things that you're popping up and all, because I'm aware that these are open source software for most.
That's exactly right.
But if I want to use what you're proposing here, what's the the HP story, Ezmeral and so on.
That is exactly right. So what is actually you are seeing here is effectively proprietary with what the HPE Ezmeral team has built.
The private cloud AI that you're talking about.
That's right. And private cloud AI is effectively the software component. The majority of the software components on private cloud AI are made up by the HPE Ezmeral stack, which is being presented here as HPE AI Essentials. So that is the offering, the flavor, if you will, of Ezmeral Unified Analytics specifically for private cloud AI. And so to answer the question in terms of do you need to have to buy the specific offering around private cloud AI, that is to say, as a bill of materials, I need to buy the underlying infrastructure as well? Not specifically. You can also purchase AI Essentials separately and install it on your own infrastructure. That
Yeah,
infrastructure.
it was also to understand kind of the deployment model, right? Because you're talking about procuring some on-prem infrastructure, but is that something that you can consume also a similar offering in GreenLake, for example, or if there's something like that? Right?
I think I understand the question now. Yes. So everything that you are seeing here in terms of that orchestration of connecting software and authenticating software here is on the HPE Ezmeral software. Removing this particular stack, but still deploying things like Airflow, Spark, you can certainly do manually, and you can consume those resources through a GreenLake contract. That's exactly right. Just want to confirm that answered the question before we continue.
Partially, but
Okay.
Please go ahead. Thank you.
Well, I'd love to chat with you after offline about this as well.
Thanks.
And yeah, so extending onto data science as a persona, same thing. I actually want to just be able to store my models, work with my models. I don't want to have to call up IT, get a virtual machine, spin up MLflow and connect it to buckets. It's done. I have logged in. I can open up MLflow here, see all my experiments through their UI, see all my models that are currently being saved, and see the associated versions with them. In fact, version 12, I can go down and see the different, in this case, there is no information about this particular model that someone was working on the platform. And as an administrator, I can see. But in the case of produce detection, for example, I can see the multiple versions here. And a lot of those have been subsequently archived as well. And how I would work with that in a notebook environment, again, I would need to connect MLflow to my notebook environment. That's all manual infrastructure work, software and hardware. Import MLflow. Update my authentication token. Instantiate an instance of the MLflow client, and I'm done. That's it. I've logged in as a data scientist. Now I can start running training jobs, working with models.
So it appears that this stack is mostly you guys curating the open source tools that are out there for client.
That's yes, as a base offering. And the reason I guess we do that is to ensure that there is an immediate value proposition for someone.
Yeah, I understand why, because otherwise you're integrating them all yourself. Okay.
Of course.
Of this stack or maybe you're going to get into this, of the stack, what, other than the integration work, what other items are in your IP? The intellectual property from HPE.
Intellectual property is going to be a little bit of a tough one, particularly around the software layer, but really that infrastructure work and everything underneath all of the top level applications that I'm sort of showing off here.
Okay.
That is really HPE's IP.
Well, you mentioned up front, you did use the word Ezmeral up front.
Yeah.
And Ezmeral was, to a certain extent, was the purchased companies that came in and became Ezmeral.
Right. Multiple.
So multiple ones, Blue Data, MapR, et cetera. Of those guys, what is included into this stack here?
So those that probably have seen Blue Data's offering previously was...
It's been a long time.
I know.
I forgot it all.
Believe me, don't I know it. It was a container orchestration platform.
Yeah. Okay.
Going beyond just that infrastructure layer, that was that top UI experience. That's
the UI. The UI piece of it.
That's right, mature and develop. But there was also integrations with Kubeflow to be able to deliver a Jupyter Notebook server on top of that or those containers. In the same vein as well. I'm trying to think of other things. Model registry was also built in. That was around with ML as well. So whilst that wasn't proprietary to Blue Data, they saw value in taking open components from open source and just delivering them on the platform, because really what we're delivering here is an underlying infrastructure platform, software and hardware, where people can actually bring their own tool sets as well.
Okay.
As long as they can be deployed as a container, they can be deployed on the platform. And that's really important as well, because that authentication and that connection to other applications takes place. But what we did is we realized that who we were building this for are those end users working along the machine learning operations workflow, and there were going to be open source tools that we're going to use anyway.
Okay, so on looking at, and you guys tell me to shut up if I'm asking too much, you know how to do that. The other piece on this is that you've talked briefly about the data. Mm-hmm. We all know the data is a pain in the whatever. and getting that data. It looks like the way this operates is I need to take whatever data. Let's say I've got my data in, some filer or sitting over in some structured database on a Nimble box or something. I need to go and port that or ETL that into this box in order to work on that box, and then from there you're going to be classifying it and doing all the privacy and everything else, and that's what's going on in that.
That is going to be a part of that data engineering workflow. Yes.
Okay.
That would be.
So I do have to bring everything and centralize it within this space, as opposed to having a data lake where I can just kind of keep on pumping it into it or something like that.
At least in terms of, so in the case of a large structured, an existing database somewhere that I can create a connector to. So
you do have connectors.
That is exactly what we.
Okay, did I miss that?
So that's exactly what we saw as far as these data connectors here for that structured data connectors.
Okay.
And also for object stores as well. These are all connectors. The data itself isn't ingested into the platform. They are all.
MinIO, there you go.
Yep. They are all connected. And so we're only bringing in data that is going to be relevant to a use case at any given time. We can store it temporarily as well and rehash those queries as well. We have a way to be able to store assets, for example, that we perform query. We perform an SQL query. I don't have to perform it every time. I can have it here.
Okay.
And before I continue, I just wanted to ask if there are any questions online. No. Fantastic. So where are we up to now? Well, as a data engineer, I have done my job. I have managed to create connectors to structured data sources to be able to perform SQL queries in real time. Generating those SQL queries, well, I'm going to need a model to be able to do that. And my data scientist has created a little model that will be able to take the answers from those queries, the results from those queries, that's the one, and be able to perform quick levels of detection that I can pass contextually to something that is going to engage in the conversation with an end user, such as a large language model. So, but in this case, for my application, I don't need one large language model. I actually need a second generative model that hasn't been trained on chat, but has actually been trained on turning a lateral language query and a database schema as input, a table schema as input, and generating an SQL query as output. One such model is SQL Coder. And what I can do is now deploy SQL Coder, and that large language model, say in the case of, something like Meta's Llama 3, or 3.1, and most recently 3.2 in the series that just released late last week. I can take those models and I can deploy them as an endpoint. Now, there's a few different ways I can do this. Traditionally, I can do that on the platform as well. I can perform the manual steps. I can take a model, the model file from a model registry, say something like Hugging Face or NVIDIA's model registry as well. I can then put it through an inference engine. There are many open source libraries available. VLM comes to mind. FastLLM is another. And I then use that inference library to take that model file, store it into GPU memory, and now I have functions that those libraries have provided to be able to interface with that model. Invoke a response, as it were, in the case of one particular library. I ask a question, get an answer. But that's not how end user applications work. There is a front end, and they connect to the back end more often than not through an API. Some endpoint connection that I can send a particular query to and expect a particular response. So, that would be in our interest to take that model and that inferring library and wrap it around a REST API serving library. If I put all of this and deploy it as a container, then what I actually have is a containerized instance of a large language model. And of course, containers on a platform like Private Cloud AI that is leveraging an underlying Kubernetes distribution, I can automatically scale that container out as needed, depending on whether I'm having one end user using our level 1 support or I'm having 100,000. With the underlying infrastructure available, we can automatically provision and automatically scale that out across the available compute within a Private Cloud AI cluster. When you purchase a single Private Cloud AI, it can extend to other Private Cloud AI instances and leverage the underlying infrastructure of those offerings. And that's a very important part. We want to protect the AI investment that people are making. You're not just buying one private cloud AI and setting another one up next to it, and then you are restricted by that infrastructure within that solution. No. You can buy a small, buy a large if you need to extend it, and the same control plane can extend onto those nodes that are coming in that environment. And that is where we can automatically scale and provision. And as far as I, as an end user, a data scientist or a machine learning engineer in this case, that is completely abstracted from me. I spin it up and we're good to go. And so what would that otherwise look like for a large language model? Well, if I pop into here, I'm currently actually building a little notebook to work with large language models, but I think I have my notebook up here. That's not the one. I apologize that it's not as beautifully formatted as the other. But what I can do is firstly see my endpoints. Now, when I spin up a large language model, there's one of two ways I can do it. As I said, I can take that container, and the way I would deploy a container that has an endpoint is I would need some kind of serving library for Kubernetes. Well, the Kubeflow community, very thankfully, developed a little add-on called Kserve. And it's a native add-on, comes pre-installed and pre-configured with AI Essentials that allows me to run a Kubernetes command with a file, a configuration file that tells Kubernetes how to deploy that container and how to scale it. And then I'm done. I have an endpoint with a large language model. What we have worked with is be able to take that container and store it locally in either a customer's local repository. We provide those images. And the files themselves, the model files themselves, keep in mind, they are in the gigabytes. They do not need to be actively retrieved, say in the case of spinning up not just one instance of this container, but I want 100. I then need to pull from storage somewhere. And if I'm pulling from a model repository somewhere else, that's going to take some time and some network bandwidth. So we actually provide that model file within private cloud AI. And this co-engineering with NVIDIA is only going to continue as they themselves continue to engineer their NVIDIA AI Enterprise stack. And I'm going to go more into what that is in just a moment. With us, because whilst their toolhouse is being able to take their libraries and their frameworks and wrap them up as components, our wheelhouse is to be able to take software and provide it at scale, enterprise scale, the biggest scales in the world. So together, we are working on developing these, particularly in containerized applications, such that they do scale, and they scale easily and quickly. And so when I deploy something like a Llama 3, I can actually show you what that endpoint looks like here, because I apologize for the end user interface that it was a quick little application I put together. And I'm a very big stickler for UI and UX design. So can't say it's my proudest work, but what I wanted to see here is a way to very quickly see my model endpoints, be it the ones I'm working on, the ones I have access to, or my colleagues. Now, for those that have built a generative AI application, leveraging the large language model hosted by somebody else, a cloud provider perhaps, an OpenAI, Microsoft, Google, Anthropic. What you are given is an endpoint to an instance of that large language model. That is now what I have here. I can copy that URL. In fact, if I want to, I can actually see some of the models actually running and the resources that they are currently on top of. So in the case of the large language model that I spun up, again, formatting can be a lot nicer. It was just a quick retrieval there and put it into a table. But I can see that every single instance of this model, if I choose to scale it out, and I could have it here as well for how many times I have scaled it out. So scaling is currently just set to 1. But I can grab my endpoint here. I know what model it is. I can pop back into a notebook environment. I can pop back into a application which, you know what? I'm going to actually install it very quickly for you all here. I'll call it a virtual assistant. I'll pull it for the AI data field infrastructure field day. Pop it in my data science category. Yeah, please.
Is it a templated structure of endpoints then? So just depending on the container that you've built, I guess it just recycles the endpoints that are there for that container and just creates a unique endpoint for them.
That's right.
So that you can do get, put, delete, all these things that you normally need to do when you're.
That's exactly right. So again, what we've worked with NVIDIA is all those components I mentioned about pulling a model, wrapping it up so it's easy for people to infer. They've done that work, and we want to be able to deliver it at scale.
And just to go back to your containerization point as well, so are you saying that the properties of a container can propagate into another container, or you can extend an existing container, so you could effectively baseline using a container and then extend on top of that as well? Is that what you meant before?
Not so much extended a container. You can obviously dynamically manage the resources of a given container. I can give it more resources if it needs a bit more grunt, that one instance of a model, or I can reduce it. But I can also replicate that container. And the great part is it ends up actually being the same endpoint.
So I guess that's what I mean with the baseline data architecture underneath. I want to use it effectively as a template. So I duplicate or copy the container and then extend from there in terms of,
that's pretty much it. And it all extends to a pod. So whilst that pod is being replicated, I can also have that same endpoint as well. Or the containers in that pod, I should say. I'm trying to find my little chatbot image, so I apologize there, folks. There he is. That'll do for the moment. Now, the way in which, of course, a container is deployed on top of a Kubernetes environment is by giving it Kubernetes instructions, a blueprint, if you will, on how to deploy any given container. And we do so, the framework for that, the most common framework to do it is a Helm chart. So most applications that you will find that are cloud native, that most software vendors will offer to spin up on an AWS GCP and their Kubernetes environments, they will offer a Helm chart more often than not. So you can import that Helm chart here if you wish to drag and drop it. I'm going to grab one here, which is actually not appropriately named for this instance, and I'm going to pop it in a specific namespace. I'm actually going to pop it in my namespace here. That'll do. Make a few changes to that chart so it grabs the right container. And I'll call this virtual assistant, so I can also delegate the endpoint. And folks, this is actually a virtual endpoint. Folks, this is how, more often than not, an application is going to get deployed on an environment that is working with Kubernetes. But here's the important aspect. This is an application, a piece of software that has, as you alluded to, is the culmination of the acquisitions that HPE has made in this space. This is a user experience that what we have today is that I can make quick modifications if I wish. And there is a little bit of a learning curve, obviously, to having to work and deploy with applications on Kubernetes. More often than not, a Helm chart will be pre-packaged and ready to go. So that I only have to make a quick modification so that it is natively supported by the other applications and the connectors within AI Essentials. And that's all available in our documentation. But even then, as we continue to develop this platform, that will be abstracted into a click-through UI. I can deploy not just an entire application like you're about to see here, but I can also deploy a large language model instance through a click-through. In fact, that is something that my colleagues are working on this very second, in the case of being able to take a large language model instance delivered by NVIDIA. In the case of what I mentioned earlier, taking a model file, inference library, and putting it in a REST API server, that is what NVIDIA are referring to as a NIM. And they are providing NVIDIA NIMs for not just a large language model, but also an embeddings model, a model that is trained to take different formats of text and images and turn it into vectors, which is the flavor of data that large language models like to operate with. So retrieval and various different models as well. So a larger instance of Meta, and this catalog is only going to grow, as we continue to co-engineer this with NVIDIA. I think I just saw a cat walk past Max's screen there.
You did.
Yes, so that's pretty much what I wanted to go through, guys, is I now have this. Yeah. Oh, did I see a hand up? No, just want to check. So I now have this this endpoint here. I now have an application, not just that, but it's all connected here. So I'll import some libraries. There are a lot of them here because I was being overzealous with some of the things I wanted to do in this notebook. That's okay. In terms of working with grabbing data from, say, an S3 bucket, I had some PDF files put in there, a local S3 bucket, and I was going to create a little vector database with it in this notebook environment. But what I'm going to do right now is actually take that same endpoint. It's already here. Oh, yep. Oh, is it just formatting there? HTTPS. One is going to be an external facing endpoint, one's the internal endpoint. They'll work just fine. And I'm going to actually firstly update my token so that I can speak with that particular container from this environment. My kernel, that's why this particular notebook kernel isn't running. Let's spin it up, shall we? And what I can do from this notebook environment is infer that endpoint. Now, keep in mind, this notebook environment is a container. The application I just spun up and is currently being initialized. In fact, if I refresh, it's probably going to be ready to go. And there it is. I'll show you that in just a moment. That, if I point it to my large language model endpoint, can also infer and work with that model. And I want to go back here so I can demonstrate that. So I can import this as well. Right, so very strange, the kernel is running. That's okay. We'll run that here as it goes along. I think that someone is me.
Someone
Didn't give the appropriate resources to this specific notebook. So I actually copied this. This is in a shared, funny you mentioned as well. This right here is a shared, this particular shared folder here is a shared PVC, a persistent volume claim. And that volume claim is sort of like think of it as like an ephemeral storage, right? Mm-hmm. That is actually tied to the underlying GreenLake for file that comes in private cloud AI, so that obviously access and identity management pending, every user can actually share those volume claims as well together. So everyone can see these particular files like this. So yeah, I would love to be able to show you this if I have actually provided the appropriate amount of memory to be able to perform the installations required. Yeah, I don't think I have. My apologies, folks. But for those that have worked with those endpoints, you would sort of see, and I can sort of allude to what would otherwise be happening here, is that when I make that declaration, and instead of having to write the libraries that are and the functions that are associated with inferring that model, NVIDIA have worked with LangChain, the open source library for working with large language models, and they have created a single instance of an object that I can use to work with those functions. So LLM, I work with that in chat NVIDIA instance. I pass it my URL that I've declared here. I ensure that I am pointing to the right model, and my authentication token to work and communicate with that NIM. Keep in mind, it is a container that has come from an NVIDIA repository. Even if it's local, we've grabbed it from NVIDIA. It does require an NVIDIA API key. And because it's on private cloud AI, that key is the same token that we used to authenticate this notebook to connect to that endpoint in the first place. So we're just passing it through as a parameter. We can then invoke with writing a ballad. I like to write a ballad about somebody here in the room, but in absence of actually having this particular notebook prepared, and I do apologize for that, folks. You can sort of see what we are doing here, right? We're going to that endpoint, we're saying invoke, and that invoke is taking our parameter that we are passing here, which is just a query. It is turning that into a JSON request to send over this API server to that endpoint, and what it's going to spit back, result.content, is that library's abstraction and unwrapping of that API response, which in this case is the content component from the large language model. And there we have it. We're able to spin up and manage large language models on a platform, and what that would otherwise look like, not just in a Jupyter Notebook environment, but as a endpoint environment in the case of a end user application. And this is something that I also crudely put together for presentation about a month or two ago. And again, I would love to be able to show that chat aspect here today, but this particular application, the way I was developed, was for a different endpoint structure, is to be able to then drag and drop files in real time to be able to vectorize and embed. So embed and vectorize. So now I have context, whereas by the large language model, before just answering my query, can go and retrieve from the vector database instance, I should say, of that PDF I would upload. It's going to take that PDF and break it up into chunks. Any given query can then retrieve relevant context from that database, which will then be used as context to augment the generation of its answer in what is the technique known as retrieval augmented generation. Yeah.
So a quick question about your infrastructure here. It's, I mean, this is really cool stuff. I was hoping you would touch on it, and I want to get you to say something about it before you wrap up. What about the diagnosability and auditability of the entire infrastructure framework?
Yep.
Because what you're showing is really cool for the data scientist, but you need the manager to be able to see what's going on in this as well.
Yep.
So that's
absolutely
okay.
And so, so on the reporting side, at least from the AI Essentials piece, so for that AI administrator, I do have complete optics over resource management in particular. Any given user, but also the administrator will have various levels of notification. So there is a back-end logging framework. There is also native support for Y logs. It's just actually, at this case, abstracted in terms of a tile that also appears. All the telemetry associated with the infrastructure is going to be working through OpsRamp and our acquisition of OpsRamp for not only infrastructure management and observation, but reporting as well. So that's going to be working up and down the stack. That integration is just currently not available for demonstration. Does that answer your question?
Yeah, I mean, that covers an awful lot of it. The diagnosability would be another question. It's like, you try to put together one of these environments and it doesn't work right.
Yep.
How easy is it to figure out what's gone wrong? I mean, you did it very quickly in your application, but it's the same thing doesn't apply to the entire environment.
That's exactly right. And I suppose that's probably a great opportunity to throw it over to my colleague, Ed Holden, more because I think he has been feeling a little bit left out. So, Ed?
Yeah, so I mean, I guess there's a couple different aspects, right? So first off, as this product is released, we've designed an entire center of excellence around it. So we have a COE dedicated to private cloud AI. So if a customer does have an issue or a question, they have a single phone number to call in. They don't need to figure out, oh, do I call Ezmeral team or do I call NVIDIA? It all goes through us. We are the support all the way through. If it has to do with some NIM, some NIM issues, we'll get NVIDIA involved. At a level 3, if that's required. But otherwise, we're going to handle all issues coming in, and we'll work the customer through that COE. Now, as far as what Alex was doing in Jupyter Notebooks, if you need help with that, obviously, I think we're going to rely on. Depending on where those come from, I think data scientists are going to have to get involved. But as far as the overall system and how it works, and the NIMs and pieces that come with NVIDIA, the Kubernetes aspect of it, we're managing. But we have the different folks that will be aligned and ready to accept any kind of calls and questions for the entire solution stack.
Great. So just a question that had kind of circulated among us that have been listening. How exactly does VMware Cloud Foundation play into this?
It's we have that as part of we call the control node. So it's basically the control plane runs in VMs, right? So that we're going to have a VM for the control, the private cloud control plane that connects back to the GreenLake platform. We have Ezmeral kind of control plane running in VM. So there's a couple of VMs needed, and then some of the we're leveraging some of the automation that was originally released as part of Private Cloud Business Edition. So we're doing kind of the one-touch upgrades for the infrastructure through some of the vSphere resources. So again, it's nothing that the customer really touches. It's kind of behind the scenes, but we are using that to kind of manage the VMs and then initiate some of the one-touch upgrades for the infrastructure piece, so firmware upgrades, patches, and things like that.
Okay, great. Thanks. That answered a handful of questions, especially between the two of us.
Yep.
No problem.
I think just to wrap up the time, for the sake of that third session, I'm just going to quickly pop back to my slide deck, if I may.